Hello everyone, welcome back to the class operating system. Last class we have studied about the introduction to the operating system and operations of operating system. So in that we have studied introduction part, what is an operating system and the view of an operating system and the definitions, the different point of the person depending on the person, the operating system's view may differ and the view of an operating system, how the operating systems are looks like. Okay, so these are the things which we have discussed in the last class, and also we have discussed about the operations of an operating system. So in that we have discussed about program management and resource management and also security and protections. So these are the things which we have discussed last class. So now today we are going to discuss about efficiency, system performance and user convenience. So this is the one of the goal of an operating system: efficiency, user performance and also user convenience. So these are all the operations and the goals of an operating systems. And also we are going to discuss about the classes of operating system. So what are the different classes of operating systems are available? In depth we are going to talk about in that. Okay. See, in this, we are going to discuss about, in this video, today's video, we are going to discuss about efficiency, system performance and user services. Okay, so how to calculate the efficiency? So we have talked about the efficiency, system performance and user services and all. So how to measure all those things? Efficiency, how to measure, and system performance, how can we measure the system performance, and user services, how can we measure? So all those things we are going to talk in this video. And also I'm going to give the basic introductions of the classes of operating system. So the batch processing system, multi-programming system, time sharing system and real-time operating system and distributed operating system. So these are all the five classes of operating systems. Okay, so I'm going to touch about the basic things of this batch processing and also a multi-programming, time sharing, real-time and distributed operating system. So before going to see this efficiency, system performance and user services, first we need to talk about computing environment and nature of computations. Computing environment and the nature of computation. So what do you mean by the computing environment? So the computing environment is consisting of a computer system and it interfaces with the other systems and the services provided by its operating system to its users and also their programs. So the computing environment is nothing but a computer system. So that particular environment which contains the computer system, so that computer system is interface with the other systems and the services provided, that computer system which provides the services through the operating system, to whom it will provide the services, to the users and also a program. Okay, so this is nothing but the computer environment. Now what are the evaluations of this computer environment? Non-interactive computing environment, interactive computing environment, real-time, distributed and the embedded environments, and also the modern computing environment. So these are the computing environments are available. Now, what do you mean by the non-interactive computing environment and interactive computing environment? See, the non-interactive computing environments, it's nothing but it is focusing on the efficient usage of resource. Non-interactive is nothing but it will not be interact between the interactive one. Okay, so between the users and also a computer systems. So it is only focusing on the resource sharing, efficient usage of the resource. Okay, so the computation in the form of program and job. So the computation which performs based on the programs and also a job. We'll see what is the program and what do you mean by jobs and all. Okay, so non-interactive environment, it will not be interactive. So the main goal of this non-interactive environment which focus only on the efficient usage of resource, and the computation which is in the form of program or job. Okay, so now the interactive computing environment. See here it is an interactive system. So The OS focuses on reducing the average amount of time required to implement on interactions between the user and his computations. So between the user and then computation, it is mainly focusing on reduce the computation time, reduce the amount of time required to implement that interactions. So it will mainly reduce the interactions between the computer and also a user. So the executions of the program is also called as process. So this is called the non-interactive and also a interactive computer environment. So what we are going to talk, it is on classes of operating system. So that classes of operating system, it may be an interactive environment or it works maybe on the non-interactive environment. Let me see what are those things. Okay, so we have talked about the program, jobs and process. Now we'll see what do you mean by the program, what do you mean by process, and what does a job means, what is a sub request is and all. So the program, it's a program is nothing but is a set of functions or modules. The program is a set of functions or module that includes some functions or modules obtained from the library. Okay, so the program is nothing but what? It is a set of instructions. So okay, so that instruction, it is nothing but what? It is a set of functions, or it may be on kinds of modules. Okay, so that module, whatever the function which is obtained from the library. If it is a model, we have to take the components from the libraries. Okay, so the program is nothing but the set of instruction, that is set of functions or modules which including the sum of functions and modules which is obtained from the library. Okay, now job. What do you mean by job? Job is a sequence of program that together achieves the common goal. It is nothing but a sequence of program, okay, that together achieve the common goal. It is not a meaningful to execute a program in a job unless the previous program in a job have been executed successfully. Job, just remember, job is nothing but a sequence of program. Okay, now what is the process? Process is nothing but the executions of a program. It is nothing but process. So the program is nothing but its set of instruction. To execute the set of instruction, the set of environments which is required, that is to store that particular program we need a memory, and also to execute that particular program we need a computer, I mean the CPU which is required, and to store the outputs we need some other kinds of memory, or to print the outputs we need some other resources. So whatever the resource which is allocated to it, by using that resource it is going to execute the program. So it is called a process. Okay, it is called process. And sub request. Sub request is a presentation of computational requirement by a user to a process. The presentation of computational requirements by the user to a process. So the request is nothing but one of the request from the user, or it may be from the program. It may be from the program. So the each sub request that produces the single response which consisting of set of results or actions. Set of results or actions. Clear? Sub request is nothing but the request which is submitted from the user or comes from the user, or it may be on program. So that output is nothing but a single response. So that single response is consisting of set of results, or it may be an action. For example, the user wants to open the file. So for that the user is sending a request through the clicking the mouses. So once if it is click the mouse on that particular file, that particular thing must be open. So it is nothing but a request. The request is submitted by the user. So that action, what is the action from the computer system? It may be an action or it may be a result. That is, it is showing that opening window. So the circle which is rotating on the window. So that means that it trying to open that particular file. So that actions will be reflected on your desktop or whatever the computer. It is one of the example of sub request. Okay, so these are the key terms which is used in this computational environment: program, job and process, and sub request. Okay, now we are going to talk about the efficiency, system performance and user services. So we know that there are two fundamental goals of an operating system. One is efficiency and also a user convenience. So already we have talked about the goals of an operating system. There are three goals of an operating system. One is the efficiency, user convenience and non-interference. So these are the goals of an operating system. But In that, what we are going to talk today, the efficiency, system performance and user services. So in that, efficiency and also here the user convenience is a main goal of a fundamental goal of an operating system. So the efficiency is nothing but what? Efficient usage of resource. I want to find out whether that resource is efficiently used by the program or request, program or the computer or the user request. And the user convenience, the user conveniently using that particular application or executed that particular program. So that can be measured based on the turnaround time and also a response time. Okay, so the user convenience we are going to talk. So we have talked about the user convenience. So that user convenience, how to measure? So based on the user services. So the user comfortably using that particular applications, or the how many number of programs are completed during that particular time, or easily can access that particular thing. So that depending on that we are going to calculate the user convenience. We are going to measure the user convenience. So in terms of turnaround time and response time. Based on that, we are going to measure the user convenience. Is it clear? Now, the third one is, what is that? System performance. So, to a system administrator, or the performance of a system in its environment is more important. Okay. System performance is more important. How can we calculate the system performance in its particular environment? So that can be calculated based on throughput, measured as throughput. Based on the throughput, we are going to calculate the system performance. Is it clear? So the term we have talked about the efficiency, system performance and user services. So these are in these three, efficiency and also a user service is the main goal of an operating system. Okay, so this can be calculated by the efficient usage of resource and also the turnaround time and also a response time. By using that, we are going to calculate the user convenience, and then system performance can be calculated by throughput. Now we are going to talk about what do you mean by the efficiency, what do you mean by the system performance and the user services. That means the measurements of efficiency, system performance and user services. So in measurement in terms of throughput, turnaround time, response time and the efficiency. So efficiency, I have told you that depending on the efficient usage of resource. So what are the resources now? We have the basic resources are CPU and also a memory. That is a basic resource which is available. Okay. So the efficiency of use, that means in terms of resource. So we are going to calculate CPU efficiency and also a memory efficiency. How to calculate the CPU efficiency? The percent utilization of CPU. The percent utilization of CPU. So how much percentage that particular CPU is utilized for that particular period. So that is called the CPU efficiency. Based on that, we are going to calculate the CPU efficiency. Similarly, the memory efficiency. So the memory efficiency also going to calculate based on the percent utilization of memory. Memory utilization percentage for that particular time. Okay. So based on that, we are going to calculate the memory efficiency. And the next is system performance. So I have told you that the system performance is calculated through the throughput. What do you mean by throughput? Throughput is nothing but the amount of work done per unit time. The amount of work done per unit time. So the number of works are completed per unit time for the given time. It is called throughput. So based on that, the system performance can be calculated. Okay, so the user services next. So the user service can be calculated through the turnaround time and also a response time. What do you mean by turnaround time? So the turnaround time is nothing but the time to complete a job or a process. The time to complete a particular job or a process, which is called the turnaround time. Response time is nothing but the time to implement the one sub request. The time to implement one sub request, which is called the response time. So we'll see in detail about this throughput, turnaround time and also a response time. So the definitions for this throughput is the average number of jobs, programs or process or sub-request which is completed by the system in unit time. Completed by a system in unit time. Okay, so that is nothing but the number of requests from the user. Okay, so it may be on job, it may be on process, or it may be on program, or it may be on sub request. So that will be completed by a system per unit time. So it is called throughput. So based on that, the number of jobs are completed per unit time. So based on that, we are going to calculate the throughput. So by using the throughput, we are going to measure the system performance, how the system performed. Okay. um, okay, next is turnaround time. So the turnaround time is nothing but the time for submission of a job, program or process by a user to the time its result become available to the user. So the time taken between the job submitted for a execution to the results available to the user. So that is called the turnaround time. So for example, the job which is submitted at the time T0. So the result which is available at the time T5. So the throughput turnaround time is nothing but the time taken between T0 to T5 is nothing but a turnaround time. T0 to T5 is nothing but turnaround time. So the turnaround time is nothing but the time for submission of a job or program or a process by the user to the time to its results are available to the user. That is called turnaround time. And the next one is response time. So what do you mean by response time? The time from submission of a sub request by the user to the time a process respond to it. It's a time taken between submission of a sub request by the user to the time to process respond to it. Time a process respond to it. The respond time from the submission to the respond by the system. Okay, so this is called the response time. So based on that, we can measure what is that, the system performance and efficiency and user services, right? So this is about the measurements of efficiency, system performance and user services. Now the next, so both the classes of operating system like on batch processing system and multi-programming systems were implemented in the year of 1960. But the main concern of this multi-programming operating systems are resource utilization. So that is the main concern of this multi-programming operating system. And the key concept which is used in this multi-programming system is program priorities and preemption. Program priorities and the preemptions. In multi-programming systems, say the multiple programs which executes at a time. Okay, so that the resource utilization is very high in this multi-programming system when compared to the previous one. Okay, so how to utilize this resource? I mean the resource, how the resource will be allocated to that particular request. So that it is based on the priorities. It is based on the priority. If there is any high priority interrupts or high priority programs are occurs, so during that time immediately that the request, that is whatever the resource which is required, that immediately preempted and put back to the, again that particular resource will be allocated to the requesting programs. So this is called the main concern of this multi-programming operating system. So in these two multi-programming operating system, the batch processing and also a multi-programming system. So earlier days, the computer hardwares were expensive. Okay, so the batch processing and also a multi-programming which is focused on efficient use of CPU and other resource in the computer system. So that's why these two classes of the operating systems were implemented. Okay, so in earlier days the CPU utilization is very less, because after completing the one job, what is that, programmer need to insert another job under the CPU for execution. So between the switching between the one job to the another job, there will be CPU, there is a possibility of CPU will be in idle. So that the batch processing system when implemented. So in that, the group of jobs are combined together to form a batch, and that batch will be sent for the execution. So the operator must involved only during the starting and end of the batches, so that it is effective utilization of the CPU. Okay, so in multi-programming system, it will not be in idle. The resource, whatever the CPU, whatever the IO, it will not be in idle. So any one of the program which executes under the CPU and also a input-output devices. So the multiple programs which is present in the memory. So one program, if it is executes under the CPU, the another program which executes under the IO operation. So there is a effective usage of resource. Okay, so this was the main motive behind this batch processing and also a multi-programming system. And the next one is time sharing system. So the time sharing systems were implemented in the year of 1970s. So the main concern of this time sharing system is good response time. Okay, and key concept which is used in this time sharing system is time slice, round robin scheduling, So in time sharing system, which use the concept which is called round robin scheduling, that is, which in turn the program or the process or request will execute under the CPU. Okay, so the time slice is nothing but the predefined time which is allocated to each and every program. So that depends on that the program will execute. Okay, so that the good response which is given to each and every users. So the delay will be very less in between the each and every programs. Okay, so the equal delay between the each and every programs. So that is the main concern of time sharing system. So the response time is very good in time sharing systems. Okay, so to achieve this response time, here in time sharing system, the round robin scheduling and also a time slicing techniques are used to achieve the good response time. Okay, so this is the motive behind the time sharing systems. And the next is real time systems. So what do you mean by real time systems? So we know that the real time application, the operating system which operates in real time applications, so which was implemented in the year of 1980s. So the main concern of this real time system is meeting time constraints. So to achieve this, the key concept which is used behind this real time operating systems are real time scheduling. Real time schedulings are performed. That is, real time system is nothing but what? So we must achieve the response or whatever the action, whatever the result, that must be achieved within a predefined time. That is called the real time systems. So in that real time system, there may be two types. One is hard real time system and another may be a soft real time system. But in hard real time system, whatever the applications, whatever the response that should perform, whatever the action that must perform within a predefined time, within a deadline. So that is called hard real time systems. So to achieve that particular deadline, we have to give the priority based scheduling. So the priority must be assigned to each and every task. So based on that priority only, this real time operating system will perform the scheduling. So that's why it is mentioned real time scheduling. Clear? And the next one is, the last one is the distributed operating system. So the distributed operating system which was implemented in the year of 1990s. Okay, main concern of this distributed operating system is resource sharing. And the key concept which is behind this distributed operating system is distributed control and also a transparency. This is the key technique which is used in this distributed operating system. Okay, so the resource will be distributed is nothing but what? So the computer systems are distributed among the network. So that will be shared. The single network will shared among the multiple computer systems. So that the particular nodes. So that node, it may be on computer system or it may be on computer system or PC, or it may be on anything else, cluster also. Okay, so if any one of the systems are fails, then immediately it will switch the function to the another operating system. So the another computer which is connected to that particular network. Okay, so that the resource will be shared among the computer which is connected to that particular network. Okay, so when compared to the other operating system, here there are more number of resources are available. Okay, and here to achieve that resource sharing, we have a key concepts are the distributed control and also a transparency. So the control is distributed among the computer system which is connected to that particular network, and then transparency. So if there is any failures occur, irrespective of the location, it can easily access that particular resource which is available in the network. So this is the basic key concept and also a prime concern behind this distributed operating system. So this is all about the classes of operating system. So today we have discussed about what is the efficiency, what is the system performance, and what is the user convenience, and how we are measuring this and efficiency, convenience, and also a user performance. Before that, we have discussed about what is a computer environment, and also we have discussed about the classes of the operating system. So what are the different kinds of operating systems are available, and what is the prime concern of that, and what is the key concept behind that particular operating system. Okay, so this is what we have discussed today. Clear? I hope this video is useful for you. We'll meet you in the next video. Thank you all.